After watching the entire process of refurbishing helical gear in Pakistan, I finally understand why they are known as the world's hand crank mechanics. Due to damage in part of the helical gear, they decided to refurbish the existing gear to save materials. The master craftsman mounted the over 1-ton gear on this vertical lathe. As the sound of the cutting tool against the gear began, metal shavings fell like snowflakes. The once sharp teeth gradually dulled quickly, revealing the original metallic color. Next, the master adjusted the cutting depth again. The turning process was noticeably more strenuous this time, and the cutting tool began emitting smoke. Eventually, under the force of the resilient iron, the entire surface became smooth and flat, making it ready for new gear teeth to be machined. However, before machining, the now smooth iron billet was placed in a furnace to ensure the smooth creation of the new teeth. The master conducted annealing through physical heating. As the furnace temperature steadily rose and reached over 1,000 degrees, the red-hot iron billet was slowly lifted by a crane and then moved to the corner to be buried for insulation, achieving slow cooling. This process effectively reduces hardness while improving plasticity and toughness, making it better suited for subsequent machining. The following day, the master transferred the cooled iron billet to the lathe. After carefully adjusting the concentricity, the billet underwent a layer of detailed turning. Of course, to achieve standard dimensions. After turning to a certain extent, the master used a precision oil gauge caliper for accurate measurement and marked the new groove positions. He then adjusted the angle of the cutting tool to carve a groove in the center of the billet, which was a long and tedious process and tough on the cutting tool. Finally, after changing the cutting tool twice, the groove was completed. The inside of the billet also needed adjustment because the gear shaft would later be custom-made according to the inner diameter of the billet. Here, the master focused on a meticulous and freehand turning process. In the end, under the master's precise machining, a standard gear billet was presented before us. The most important task, however, was the gear cutting, so the billet needed to be transferred to the gear hobbing machine. At this point, the chief technical engineer took over. The master pulled out a dial indicator, carefully observing the subtle changes in the readings. Then, he gently tapped the billet with a hammer to adjust its angle and position, ensuring that the subsequent milling would produce accurate gear teeth. He tightened the nuts to secure the billet after confirming everything was correct. The gear hobbing machine slowly rotated, leaving uniform milling marks on the billet. The master closely observed the location and number of gear marks. After confirming the accuracy, he set the parameters of the gear hobbing machine, leaving the subsequent milling work to the apprentice. Each pass of the hobbing machine left a tooth-shaped mark on the billet, with iron shavings gradually piling up at the bottom and the gear teeth contour becoming increasingly apparent. The exact process was applied to the other end of the gear. However, before milling, to ensure both sides of the gear were aligned accurately, the master first scraped a layer of white paint onto the surface. He then measured it with a ruler and drew the gear alignment line. With everything ready, the gear was again mounted on the gear hobbing machine. After adjusting the concentricity, the machine began to operate slowly. Of course, this process required extreme caution. During the initial hobbing, the master carefully observed and adjusted the milling marks to ensure they aligned perfectly with the direction lines. Only after changing the position could the master confidently relax during the long milling period, heading to the office for tea and a chat. After a full day of milling, the shape of a double helical gear finally emerged. However, it still needed to be moved to the shaping machine to carve out a standard keyway for the gear shaft. After the keyway milling was completed, the most crucial step, quenching, began. Whether the gear will have sufficient strength and durability in the future depends on the details of this process. As the furnace fire flared up, the crane slowly lifted the gear and heated it to a high temperature. Once the infrared thermometer showed standard data, the gear was quickly submerged into the cooling pool. At this point, the refurbishment of an old gear into a new double helical gear was complete, with hardness measurements fully meeting international standards. So, what do you think of the craftsmanship of the Pakistani masters in refurbishing this double helical gear? If you were to rate it out of 100, what score would you give?